Hello everyone, this is the second part of nuclear physics, and in this part we are going to talk about the new discovery of nucleus and designation of atom using atomic number and mass number, and how to find the number of protons or electrons or number of neutrons in an atom, and finally we'll talk about the isotopes. Okay, the nucleus was actually discovered by Rutherford, a British scientist, in 1911 through his gold foil experiments. And here is the setup that he used. He was actually very curious to know what would happen when high energy alpha particles bombarded a very thin sheet of gold. So his setup contained a source for alpha particles, a gold foil, which is very, very thin, and he also used a screen which is coated with zinc sulfide, which produced a flash every time the alpha particle hit the screen. And this can be tested using a low power microscope. Okay, Rutherford found that the vast majority of the alpha particles went through the gold foil as if it were not present. A few of the alpha particles deflected back, and about 1 out of 20,000 alpha particles bounced back. Rutherford could only explain this behavior by assuming that each gold atom had its positive charge concentrated in a small core rather than distributed throughout the atom. He called the core as the atomic nucleus. So, combining all of the information, he was able to predict that the nucleus is going to be at the center of the atom, and the electrons are around the nucleus. So here is the major constituents of an atom. So we have an electron which is negatively charged, and the actual charge of an electron is equivalent to minus 1.60 times 10 to the power of minus 19. And the proton has an opposite charge, and it is equivalent to 1.60 times 10 to the power minus 19 coulomb, and neutrons have no charge at all. So from the gold foil experiment conducted by Rutherford, we are able to find the nuclei's average diameter, which is equivalent to 10 to the power minus 14 meter, and the atom's outermost outer electrons have orbits with diameter which is equivalent to 10 to the power minus 10 meter. So in reality, the diameter of the atom is actually 10,000 times bigger than the diameter of the nucleus. So most of the atom's volume consists of empty space. So this is like comparing the baseball stadium with a peanut. So imagine putting the peanut, if this is the peanut, and try to put the peanut in the center of the baseball stadium. So that is going to come while the peanut is going to while the peanut is going to be the nucleus, the baseball is going to be your atom. So that's how you can compare the size of the atom with the size of the nucleus. Now let's go on to the element. Element is a substance in which all the atoms have exactly the same number of protons, and we use atomic number for the number of protons. Okay, so atomic number is nothing but the number of protons or the number of electrons. There is also two other numbers that you should get familiarized with. It is the neutron number and the mass number. The mass number is actually the total number of protons plus the total number of neutrons. Okay, so this is how you will designate an atom. So X stands for the symbol. So there are two letter symbols and a single letter symbol, so depending upon the atom or the element. And you will always have a mass number which goes on top left of the atom, and also a atomic number which goes on the bottom left of the atom. So let's have a look at carbon. Carbon has an atomic number of 6 and mass number of 12. And we already know that mass number is the number of protons plus number of neutrons. Whereas the atomic number is either the number of electrons or the number of protons. And similarly, if you're going to look at natrium, which is actually sodium, it has a mass number of 23 and an atomic number of 11. Now having got an idea about mass number and atomic number, we should be able to do this problem. Determine the number of protons, electrons, and neutrons in 19 fluorine. So we know that this is the mass number and this is the atomic number. So mass number is actually equivalent to the number of protons plus the number of neutrons, whereas the atomic number is either the number of electrons or the number of protons. Now, so we know what's the number of protons available in fluorine 19, number of electrons available, which is actually equivalent to the atomic number, which is equivalent to 9 in this case. We are missing just neutrons. So, but we know that the total mass number is actually 19, which includes the total number of protons and the total number of neutrons. So because we do not know n, we can keep n to one side and bring everything to the other side. That's going to give a total of 10. So the number of neutrons present in fluorine is actually 10. Okay, now the next topic is the isotopes. What are isotopes? Atoms of the same element can have different number of neutrons in their nuclei. Okay, suppose if you take carbon, carbon can exist in 3 different isotopic forms. Okay, as you can see from here, carbon has, all of these carbons have exactly the same atomic number. Okay, which means they have exactly the same number of protons and the same number of electrons. But one thing that is different in this is the number of neutrons. Okay, or the mass number is different, which in turn comes from the number of neutrons. So you can see that the mass number or the number of neutrons in carbon 12 is actually 6, whereas the number of neutrons in carbon 13 is 7, and for carbon 14 is 8. And because they have slightly different mass, they are going to have different chemical reactions.